In this video, we are going to talk about the numerical integration. So why do you need the numerical integration? We know that we know how to find out the integration by substitution method, right? We know how to find out the integration or the entire derivative by the taking the inverse of the derivative, right? So there are other techniques of finding the integral which you will see in calculus 2. But still, after you are done with calculus 2 and calculus 3, all those integral techniques, there are still some functions that there are still many functions that it is hard to find out the integral by hand. Okay, so in such case, if a function has a complicated type of integration, or if it is hard to find out the integral manually, then what we do is we use the numerical methods to find out the integral, or to find out the area under the curve, right? There are many numerical methods. So some of them are trapezoidal rule, Simpson's rule. There are many methods. Okay, so the simplest one and the first method and the very simplest method is called the trapezoid rule. Okay, so how do we find out the definite integral, meaning integral from a number to another number? Or you can say, how do I find out the area under a curve between two x values? Okay, so so the number one method is the trapezoidal rule. What do you mean by a trapezoid first? Trapezoid is a closed figure formed by four sides. So two of the sides must be parallel, okay? And the third and fourth side may be parallel or may not be parallel. So see here, this side and that side are parallel. These two sides are not parallel, because if you expand that, they will intersect, right? You see that? So to be a trapezoid, two of the sides must be parallel. Okay, how do I find out the area of a trapezoid? This is the formula to find out the area of a trapezoid. 1/2 of the sum of the parallel sides. You see that? These two sides are the parallel, right? So 1/2 times sum of the parallel sides times the distance between the parallel sides, that I denoted by h. Okay, so the area of the trapezoid is 1/2 the sum of the parallel sides times the distance between the parallel sides, which is denoted here by h. Okay, now what is the trapezoidal rule to find out the area under a curve, or to find out the definite integral? Is, suppose you want to find, you have a function y equals to function of x, and you want to find out the integral of a to b f of x dx. Okay, suppose this is the function y equals to f of x, there is a, there is b. To find out the area under this curve, or in other words, to find out the definite integral from a to b fx dx, what we do is we divide that interval ab, okay, that interval ab into n parts, n partitions, okay, and equal parts. So it is 1 part, 2 part, 3, 4, 5. So there are 5 equal parts here, but I have a dotted dots here, meaning that there are so many missing there. Okay, so what is the width of each of those? Because what is the total length of the interval AB? The length is B minus A, and you are dividing into n equal parts. So this will be the length of, or the width of each of these subintervals, right? So the length of each of these subinterval is B minus A over n. Now, so let us form a trapezoid. Okay, so how do I form the trapezoid? We have the three sides already. These two sides are parallel, right? This side and that side are parallel. This side and this side are not parallel, but we don't worry. So we join that with a straight line. We join that with straight line. So this is the trapezoid, right? So what is the area of the first trapezoid? I denote by a1. So the formula is 1/2 the sum of the parallel side. What is the sum of what is this height? Is fx0, right? I denoted the first one by x0, and then x1, x2, x3, and so on, and then this is xn minus 1, this is xn, because we are dividing into n equal parts. So I denoted x1, x2, x3, and then so on. Okay, so the first width is b minus a over n. The height of the lower the left side is f of x0. The height of the right side is f of x1, because at x1 the height is f of x1, right? So the area is 1/2 the sum of the parallel side times the width, or the height. You see that? Exactly the same technique. Similarly for the A2, that is same as the area of the second trapezoid, right? So what do we do? Sum of these plus that divided by 2, or you can say 1/2 this plus that, and then times the width, right? So or the distance between the parallel sides. Okay, so what do you do? 1/2 fx1 plus fx2 times b minus a over n, that is that length, right? So these lengths are b minus a over n. You see that? So similarly you can do all of those. Okay, now look at this one. When you try to find out the area under this curve, what we do is we add all these area of all these rectangles, right? What is the area of the first rectangle? Is a1. So the total area is a1 plus a2 plus a3 plus, and then so on. So what is the sum of the area? That is, so what you have is in a1 1/2 and b minus a over n is there. In a2 1/2 and b minus a. When you add all these, you can factor the 1/2 and b minus a over n out. If you factor out, what is left is fx0 plus fx1 plus fx1 plus fx2 plus fx2 plus fx3 plus, and so on. And then you do the f of x n minus 1, the one left from the last one, and then plus f of x n. That's what you get. You see that? But what you see here is, whenever you do fx1 fx0 plus fx1 plus fx1 plus fx2, see, this is repeated, right? This is also repeated. That will be repeated too, and this will be repeated to the previous one, right? But which one is not repeated is fx0 and fxn are not repeated. So if you add all these, this is what you will see. fx0 plus 2fx1 plus 2fx2 plus, and then so on up to this. The second from the last is 2fxn minus 1, but the last one doesn't have any pair. The first one and last one doesn't have any pair. So this is the formula for the trapezoid rule. Okay, that is the formula for the trapezoid rule. You see that? So the idea here is, the first one will be just 1 times, all the middle one will be 2 times, and the last one will be one times the height at the last point and 1 times the height at the first one. All of the middle one will have 2 times the height. So, and 1/2 times b minus a over n is basically the length of each of the sub interval. Okay, that's what you do. What it says is, when n tends to infinity, if you draw so many of those, then you will have many sub intervals, right? If you increase that, in that case, basically the trapezoid rule also tends to the Riemann sum. Okay, that is basically a to b fx dx. So when there are so many of these trapezoids, like tiny width, then the total area under the curve will be almost equal to the exact area, that is the integral of a to b fx dx. But even if you have fewer trapezoids there, then it approximates close to the exact area under that curve. Okay, let us see one example. Use trapezoidal rule to evaluate 0 to 2 under the root 1 over x cubed dx. Make n equals to 4 trapezoid. That's what it says. If you don't do the numerical method or the trapezoidal rule or any other numerical rule, it is hard to find the integral here. You see that? So substitution method does not work. We don't have a direct formula to find out that. So what it says is, make 4 trapezoids. This is the graph that you will get. And I want to make 4 trapezoids. 1, 2, 3, 4 trapezoids, right? So so the total length A is 0, B is 2, right? B is 2. Now we want to make 4 trapezoids. So I half that interval 0 to 2. So it is 0 to 1, 1 to 2, and I half this one and I half that one. So there are total 4 trapezoids. What we want to do is, so what is the length of each of the sub interval? This is 0.5, right? And also this will be 0.5, this will be 0.5, that will be 0.5. So width of each of the interval will be 0.5. How do I find out that? Since n equals to 4, b minus a over n is the width of each of the subinterval, right? Or the length of each of the subinterval. That is 2 minus a over 4, that is 2 over 4, that is 0.5. That's why I got the 0.5 for each of those, okay? Now to find out the integral of these, so what you do is 1/2, okay? 2 minus 0, b minus a over n is 4. I did f, x0 is basically 0. x1 is 0.5, x2 is 1, x3 is 1.5, and x4 is 2. So you see that the last one and the first one will have 1 times in the formula. You see that the last one and the last one has 1 times xn, and the first one has 1 times x0, but the middle one will have 2 times. So we will have f of x0 plus 2 times f of x1, that is f at 0.5, plus 2 times f at 1 plus 2 times 1.5 plus 1 times f at 2. That's what you will get. Okay, so what is f at 0? You just plug in what is fx. F of x equals to under the root 1 plus x cubed, right? So what is f0? You plug in 0 for x, you will get root under 1. It's just 1, right? You see that? So what do you get here is 1/4, because 2 times 2 is 4, so you divide. So 1 over 2 times 2 is 4. 1/4 times f0 is 1, plus 2 times what is f at 0.5. You replace x by 0.5, and then you will get 1.0606. that is that value. Okay, and then similarly 2 times f at 1, replace x by 1, you will get that one, and 2 times that, and then f of 2 is 3, because if you replace 2x by 2, you will get f2 equals to 1 plus 2 to the third is 8. 1 plus 8 is root 9, that is 3 here, right? Okay, so if you add all these, this is what you will get, 3.2832. Instead of making just 4 rectangles or 4 trapezoids here, if you make 1000 trapezoids, your calculator will give you that 3.2413. That's what you will get. Okay, this is what you will get, 3.2413. This is almost the exact value of the area, and this is the approximated value by 4 trapezoids, right? You see that they are almost close, so it matches up to 1 decimal place, and it is differ a little bit by after 1 decimal place. So this is how we use trapezoid rule to find out the integral, or to find out the area under a curve, or to find out the integral which is not easy to integrate by the formula. Okay, by the regular substitution method or any other type of method you learned so far. Okay, so you see that when you use the trapezoid rule, you see the difference here. With the n equals to 4 rectangles, you got 3.2832, but with n equals to 1000 trapezoids or the rectangles, you see that 3.2413. You see the error, because if you have more and more trapezoids, then you will get better and better estimates for the area, right? So with the low number of, or the less number of trapezoids, you will get a little off from the exact values. Okay, so there is a formula to limit the error. That is the error, right? The difference between the approximated value and the exact value is the error. So to limit the error, we need to have more and more trapezoids. We need to have more and more sub intervals there, right? So that's the note, error in trapezoid rule. If fx has a continuous second order derivative on AB, then the error of approximation is, the error is always less than b minus a to the third cube over 12n squared times maximum of f double prime of x, absolute value of maximum of f double prime of x. So this is the maximum of your error will be smaller than this value. That's what it's saying. Okay, your error is less than this value. Okay, we'll do one example for the error, and then we'll be done. But by the way, this trapezoidal rule is only one method to approximate the area under the curve, or to approximate the definite integral, right? There are other methods too, but in this video I'm just talking about only on this method. Okay, so you can find out other methods like Simpson's rule and any other numerical methods to approximate the definite integral. So you search that online if you are interested, but for now I am just ending on this numerical trapezoid rule only. Okay, so let us see one more example on error of the trapezoid rule. On this example, what it says is, when calculating the integral by trapezoid rule with 5 trapezoids, approximate the maximum error. What will be the error if you approximate this integral using the trapezoid rule with 5 trapezoids? Okay, so so here f of x, what is your f of x? F of x is under the root 1 plus x squared, right? How do I find out f prime of x here? F prime of x will be, it is just like 1 plus x squared to the 1/2 and then prime, right? So it is u and u minus 1. So 1/2 1 plus x squared to the 1/2 minus 1 times u prime, right? So 2x. So 2 and 2 will cancel out, right? You will get x times 1 plus x squared to the negative 1/2. You see that? And to find out the second derivative, why do I need second derivative? Because the error formula is the second derivative and the maximum value of that, okay? So the second derivative of fx is just, you have to use the quotient rule here, x over root under x 1 plus x squared, right? If you use the quotient rule, this is what you will get for the second derivative, okay? So, and if you plot the second derivative, this is what the plot look like, y double prime. This is the plot look like, or f double prime, okay? So you see that in the interval 0 to 1, even you don't need 0 to 2, but in the interval 0 to 1, because our interval is 0 to 1, right? In the interval 0 to 1, the maximum value is at 1, right? And the maximum value is 1, and it is at x equals to 0. At x equals to 0, the second derivative is maximum, which is 1. You see that? Now what we do is, so on the interval 0 to 1, f double prime of x has maximum value, which is 1. That is maximum of f double prime of x, the absolute value is equals to 1 in the interval 0 1. Okay, now, so the error is less or equals to b minus a to the cubed over 12n squared times maximum of f double prime of x. This is the formula, right? I plug in the value of b a. So this is what? This is a, right? This is a, this is b, n is 5, this is n, right? N is 5. O times maximum of this is 1. We found that already, right? So you have 1 cubed over b minus a is 1 minus 0, right? So 1 cubed over 12 times 25, that which is same as 1 cubed is 1 over 12 times 25 is 300. So which is equals to 0.003, and then 3333 like that. It is repeated after that. So what does that mean? It means that if you are approximating this integral using the trapezoid rule with 5 trapezoids, this is the maximum error you can get, 0.000333, like that. So next application of that error bound is find the value of n, meaning how many trapezoids should you take? That's what it is saying. Find the value of n, or number of trapezoids, such that the trapezoid rule approximate the value of the same integral within 0.01 from exact value. So you want to have the error less than 0.01. You want to have the error less than 0.01 from the exact value, okay? If you want to have an error less than 0.01, what you do is you plug in here, and whatever term you get, you do that thing less than 0.01. That's what you do, okay? Let's do that. So we have that f double prime of x, f prime of x is x over 1 plus x squared, which is the same thing. F double prime of x is that thing, right? Also on 0 1, maximum of f double prime of x is 1. So what is given is error is 0.01. This is also given, okay? This is given. Now the formula is the error is less or equals to b minus a to the cubed over 12n squared times maximum of f double prime of x. But n is asked, right? So n equals to what? How many trapezoids should you take? That is asked. That's why we will keep n, plug in the value of b, a, and the maximum of that. What do you get? Maximum of that is 1, right? We found out that already from this graph. So 1 over 12 times n squared, because 1 minus 0 is 1 to the cube is 1. So 1 over 12n squared. Okay, this is the error you got. Now what you want is, but we need the error less than 0.01. So that's why we do 1 over 12n squared is less or equals to 0.01. How do I solve for n? You flip. Okay, if you flip, you will get this on the top, that on the bottom. But when you flip the fractions, the inequality will reverse. That means 12n squared, it was less or equals, now it will become greater or equals to 1 over 0.01. Okay, that will flip as well, which is equals to 100. So n squared must be divided by 12 on both sides. Divided by 12, you will get n squared is greater or equals to 100 over 12, right? And if you take the square root, you will get n is greater or equals to 2.89. But n is the number of trapezoids, so it cannot be decimal, so I rounded up to 3. So this is the number of trapezoids you will need to evaluate this integral within the 0.01 unit of the true value or the actual value, okay? So we need at least 3 trapezoids. So if you have more than 3 trapezoids, you will get the error even smaller than that. But to have error at most 0.01, you need to have at least 3 trapezoids in the graph. Okay, that's what it says. All right, guys, so this is the end of the video, and this is the end of the course. For the remaining of the classes, we have 2 or 3 classes left. Okay, so you will have to work on the final exam review questions. If you have any question, you can email me. Okay, but we will stop here for Calc 1. Okay, guys, thank you very much. And if you have any question on the review problems, you should email me. And the the final exam will be similar to the other exams. I will post the exam on the scheduled exam, final exam day. I will post the exam in the website, and you guys do the problem and then submit. Okay, so that's how it works. All right.